This is the first success criteria of our second lesson, which is I can use a number line to plot and compare positive and negative integers. We've been working with positive and negative integers already with our two color counters, but now we're going to use another tool, and this is a tool that will continue through the rest of your mathematical career, and it is called a number line. So a number line is hopefully something that you have seen before, and it is a tool we use to represent the signs and relative sizes of numbers. You can see them either horizontally or vertically, and they typically are marked with a scale. So numbers to the right or above will always be larger than numbers to the left or below. The scale of a number line is the distance between its tick marks. So if we look at what I have written on number 1, you can see that to the left of 0, I have shaded that red because those are our negative numbers, and to the right of 0, I have shaded it blue because those are our positives, and 0 has a dot that is black because it is neither positive nor negative. Now, when you look to the right, you can see that we have these little tick marks. The tick marks are the little vertical hashtag marks, and I've pointed to 2 of them here. And the scale of the number line is the distance between those tick marks. So in this case, we're going from 5 to 6, which is 1. So the scale is going to be 1. Number 2, the question is, I want to plot the numbers on the number line above, and I already have them done for you, but let's just do a quick little recap on where it comes from. P is 2 1/2. So 2 1/2 is going to be halfway between 2 and 3. So we come up to our number line, and you can see that between 2 and 3, we have plotted the point that has a P right in the middle. The next one, point Q, is a negative 500%. Remember that percent means you divide by 100. So if you take 500 and divide by 100, you get a 5. So Q in this case will be negative 5. And you can see that we went to the left of 0 and labeled Q at the negative 5 point. R is 4, so we just count 4 to the right from 0. And T is negative 8, which means we go to the left 8 units from 0. Now, the next part is we want to circle the largest number. Remember, the largest number is the number that is to the right. So I'm going to go ahead and add a circle to my number line. That is the largest one. And then the smallest one, I'm going to put a box around it. So that's the one that is the furthest to the left. For number 3, we want to use the scale to fill in the boxes with the correct integer values. So this one's a little tricky until you've done a couple. So in order to figure out the scale, which we don't have, we need to think about the distance between the left edge and the right edge for the labeled points that we have. So we're going all the way from negative 16 up to 0. That's going to use a distance of 16. And then we continue on from 0 up to 34, which gives us another 34. So that means the distance in all will be 34 plus 16, which is 50. Once we know the whole distance, then we're ready to start thinking about the spaces in between. So here's our whole distance, and we can look at how many jumps it took to make up that 50. And if we count them, there are 10 of those jumps. So to figure out how big each jump is, we would need to take the full distance, which is 50, divide by 10. That gives us 5. As soon as we know the scale, we can then move forward from whichever labeled points we have, or we could move backwards from the 34. So if I move forward 10 units to get to this first box, that's like having 16 red counters, and then I add 10 yellow counters, so I end up with 6 red ones after I take out the 0 pair. Thus, this box gets filled in with a negative 6. If we then count from this box to the next unknown box, that's 4 jumps of 5. So that's going to be 20. I'm going to add 20 yellow counters to the negative 6 red counters that I have, take out my 0 pairs, and I'm left with 14. My last box, I will move forward 2 jumps or 10 to get to 24. B is done the exact same way. We would figure out the distance from negative 24 to 6, add those two values together, or I should say the positive, the magnitude of them, and it will be 30. And again, if I count my jumps, there are 10 of them. So 10 divided into 30 is going to be 3. Once I have my jumps of 3, I can add 3 yellow counters and then 3 yellow counters again. So 6 total yellow counters are being added to negative 24. If I take out my 0 pairs, I'm left with a negative 18. Do the same thing, add 1, 2, 3, 4 sets of 3. So I'm adding 12 yellow counters to negative 18 will leave me with a negative 6. Go 2 more forward where each jump is 3. I'm going to get up to 0. And then 2 more will take me to the 6. Number 4, the last problem in this video is how do we label the opposite of 3 and the opposite of 5 on the number line? So we were given positive 3 and positive 5. So the opposite, this little symbol right here, means to go to the other side of the number line. So this 3 pops over to the other side, the same distance away from 0. And the opposite of 5, or negative 5, will take us over here to this negative 5 dot. So if I want to now consider which ones of these are larger and which ones are smaller, numbers that are smaller are always to the left. So that means negative 5 is smaller than negative 3, and it means that negative 3 is larger than negative 5. So we're going to go find the statements that say that. This first one right here says negative 3 is larger than 5. So that one is true because negative 3 is to the right. This one cannot be true, the second one, because negative 5 is not bigger than negative 3. It is smaller because it's further to the left. The third one tells me that negative 5 is less than 3. So that one is true because it's to the left. And the last one is false for the same reason.